This brief lesson covers the topic of the distributive property. If we look up the word distribute, it's a verb and it means to spread out so as to cover something. But this may not necessarily help us too terribly much as we try and understand the distributive property in math. Let's take a look first at the problem shown below. In red, we have 5 times 3 plus 5 times 2. What I've shown below is a picture of what 5 times 3 looks like. I have 5 rows and 3 columns for a total of 15 squares. In green, I've shown what 5 times 2 looks like. If I add those two together, I get a total of 5 rows, and each row has 3 red plus 2 green in it. If you look at the equation up at the top, 5 times the quantity 3 plus 2, that's what I have a picture of on the right, is equal to, it's the same thing as 5 times 3, those are the red squares on the left, plus 5 times 2. When we apply the distributive property, all we're really doing is regrouping some things. In the language of algebra, here's how we show the distributive property. Some number a times a quantity b plus c can be rewritten as a times b plus a times c. This is the example that was shown on the previous page. In that example, a was 5, b was 3, and c was 2. The distributive property also works for subtraction. Some number a times a quantity b minus c can be rewritten as the product of a times b minus the product of a times c. It's like I took the a and I spread it out over the b and the c. Most of the time when we've used the distributive property this year, we've applied it in situations where we have a mix of constant terms and variable terms. Let's see what happens if we try and model an expression that we would use the distributive property for. The expression is 4 times the quantity x plus 3. So first, let's model what x plus 3 would look like. Well, x plus 3 would look like this. We'd have an x that's like a box that contains some unknown number, and we'd have 3 ones, or 3 marbles in some previous models we used. So that's what x plus 3 would look like. It's x, an unknown quantity, plus 3 more. The 4 out in front of the parentheses means that instead of just having one set of x plus 3, we actually have 4 sets of those. So here's one x plus 3, here's a second x plus 3, a third x plus 3, and a fourth x plus 3. So that's what 4 times the quantity x plus 3 looks like. It's 4 sets of x plus 3 each. If we count up then what we have in total, we have 4 x's, you can see there are 4 green boxes there, and 12 ones, there are 12 dots there. This is what we get when we use the rainbow approach to applying the distributive property. So sometimes we've drawn little arrows from the number outside the parentheses, 4 in this case, to each of the terms inside the parentheses. The first little arrow, 4 times x, that shows us that we end up with 4 x's. And you can see from the picture how if we have 4 sets of x plus 3, in total we have 4 x's. The second part of the little rainbow that we draw from the 4 to the 3, 4 times 3 gives us 12. And you can see that if we have 4 sets with 3 ones each, that we have a total of 12. So when we apply the distributive property to 4x plus 3, to 4 times the quantity x plus 3, what we get is 4x plus 12.